Hello, and welcome to this edition of the Pulse on Power Show. I'm Ed Merkel, and we are pleased to present to you this series of videos designed to demonstrate the key features that you should be considering when selecting a power supply. Today's video will focus on the importance of efficiency and what impact the heat generated can have on your power supply and other components in your control cabinet. Efficiency for a power supply is simply the difference between the input and output power, and the loss, for the most part, is dissipated in the form of heat. For a power supply, heat is the number one enemy, and the amount of heat can greatly increase or decrease the life of your power supply. Let me show you an example of how to calculate the heat loss based on the efficiency. If we look at these two 10 amp 24 volt DC power supplies, you will see that each unit is rated 240 watts, but one unit is rated 88% efficient and the other 93%. The calculations to find the input power is simple. You would take the 240 watts and divide it by 0.88 or 88%, and you get 273 watts. The heat loss is 273 minus 240 or 33 watts. The other unit is calculated the same, except we divide by 0.93 for 93% efficiency, and we get 258 of input power or 18 watts of heat loss. So the difference between the two units is not just 5%, but the 88% unit generates almost twice the amount of heat than the 93% power supply. Let's take a look at a working example of these 88 and 93% power supplies. The unit on the left is the Puls 93% efficient 240 watt power supply, and the equivalent rated brand X 88% efficient power supply is on the right. These units are wired and loaded equally, and you can see that the starting temperature inside each enclosure is approximately the same. We're going to let these units run for a while, and let's see what happens to the temperature inside each enclosure. Well, it's been a couple of hours now, and you can see that the Puls enclosure is substantially cooler than the brand X enclosure. We started out at normal room temperature, so can you imagine these units being installed on a factory floor on a hot summer day? Or what if these units were installed along with other heat-producing components, such as drives? Imagine the effect all this heat would have not only on your power supply, but all the surrounding components. Capacitors are the weakest link of the power supply, and like any other design, the life expectancy of that unit has to be rated based on the weakest component. There is an industry standard involving capacitors which state that for every 10 degrees C temperature increase, the life of the capacitor is cut in half. The opposite is also true, which is for every 10 degrees C decrease, the life is doubled. So based on the temperature readings here, you can expect the Puls unit to last more than twice than the other unit. The advantages of a highly efficient power supply is less heat is applied to the entire control system, no derating of the power supply is necessary due to heat, and you can expect a longer, more reliable control system. But the most important is the cost savings that can be achieved based on the possibility of a smaller power supply, smaller enclosure, and the lack of air conditioning required for the control cabinet. Thank you for joining us. If you have any additional questions, please call us or refer to our website where we have additional information on our products and applications. All of us at Puls thank you for joining us today, and we look forward to seeing you on our next edition of Pulse on Power.